Hello and welcome to a journey through the most fascinating story ever told. The history of our universe spans billions of years and contains wonders beyond our wildest imagination. As you settle in and relax, prepare to travel back to the very beginning of time itself. The story of our universe is a cosmic tale that connects all of us to the stars and beyond. Approximately 13.8 billion years ago, something truly extraordinary happened. From a singular point of infinite density, our entire universe burst into existence in what scientists call the Big Bang. This wasn't an explosion in space, but rather an expansion of space itself. In the first fraction of a second, the universe expanded faster than the speed of light, in a process known as cosmic inflation. The temperature during these earliest moments reached trillions of degrees, making it impossible for even atoms to form. As the universe continued to expand and cool, fundamental forces began to separate. First, gravity emerged as a distinct force, followed by the strong nuclear force, and then the weak nuclear force and electromagnetism. After about 3 minutes, the universe had cooled enough for protons and neutrons to combine, forming the nuclei of the lightest elements. This process, known as nucleosynthesis, created hydrogen and helium, which would later become the building blocks for everything we see in the cosmos today. For nearly 380,000 years, the universe remained an opaque soup of charged particles and radiation. Light couldn't travel freely because it constantly scattered off free electrons. But as temperatures dropped below 3,000 degrees Kelvin, electrons could finally bind with atomic nuclei. This crucial moment, called recombination, allowed light to travel freely for the first time. This ancient light still exists today as the cosmic microwave background radiation, providing astronomers with a snapshot of the early universe. The next phase in our cosmic story might surprise you with its apparent emptiness. For millions of years after recombination, the universe existed in what astronomers call the cosmic dark ages. No stars or galaxies had yet formed, just vast clouds of hydrogen and helium gas. Slowly, over time, tiny fluctuations in density began to grow under the influence of gravity. These slightly denser regions pulled in more matter, creating the seeds for the first stars and galaxies. The darkness was about to end as the universe prepared for one of its most dramatic transformations. The first stars began to form approximately 100 million years after the Big Bang. These ancient giants were unlike the stars we see today. They contained only hydrogen and helium, the simplest elements, and grew to masses hundreds of times greater than our own sun. These cosmic pioneers lived fast and died spectacularly in powerful supernova explosions that scattered the first heavy elements across space. With the dawn of these first stars, the universe entered a period known as ionization. The intense ultraviolet light from these massive stars began to strip electrons from neutral hydrogen atoms, creating bubbles of ionized gas that gradually expanded. This process fundamentally changed the universe, making it transparent to most forms of light, and setting the stage for the cosmos we observe today. Around 1 billion years after the Big Bang, galaxies began to form in earnest. Early galaxies were smaller and more irregular than the majestic spiral and elliptical galaxies we see in our modern universe. These cosmic neighborhoods grew through both internal star formation and mergers with other galaxies. Our own Milky Way galaxy took shape during this period, though it would continue to evolve over billions of years to come. Some of the most mysterious objects in our universe also appeared during this era of galaxy formation. Supermassive black holes with masses millions or billions of times that of our Sun formed at the centers of galaxies. Scientists are still debating exactly how these cosmic monsters grew so large, so quickly in the early universe. Their gravitational influence would come to shape the evolution of their host galaxies. As the universe aged through its first few billion years, a beautiful cosmic cycle began to emerge. Stars formed from clouds of gas, fused lighter elements into heavier ones in their cores, and then returned these elements to space when they died in supernovae or planetary nebulae. This stellar recycling process gradually enriched the universe with elements like carbon, oxygen, silicon, and iron. Each new generation of stars contained more of these heavy elements, eventually making possible the formation of rocky planets like Earth. About 4.6 billion years ago, in an ordinary spiral arm of our Milky Way galaxy, a cloud of gas and dust began to collapse. At its center formed our Sun, while in the swirling disk around it, smaller clumps of material gathered to form planets. Earth was one of these planets, initially a molten world that gradually cooled, forming a crust and eventually oceans. The heavy elements created in ancient stars now made up the very ground beneath our feet. Through an extraordinary sequence of events, still not fully understood, life emerged on Earth. From simple single-celled organisms to complex multicellular life, evolution shaped an astonishing diversity of species. After billions of years of cosmic and biological evolution, beings capable of looking up at the stars and wondering about their origins appeared. We humans are made of stardust, the products of stellar fusion from stars that died long before our solar system formed. Meanwhile, on the largest scales, the expansion of the universe continued. About 5 billion years ago, this expansion began to accelerate, driven by a mysterious force scientists call dark energy. Galaxies began moving away from each other at an ever-increasing rate, a process that continues to this day. The nature of dark energy remains one of the biggest unsolved mysteries in physics, despite constituting roughly 68% of the total energy in our universe. Around 3.8 billion years ago, on our small blue planet, the first microbial life forms appeared. This emergence of life added a new dimension to the cosmic story. Through the slow process of evolution, these simple organisms diversified and became more complex. Life survived massive extinctions and adapted to changing conditions on Earth. The universe had produced something remarkable, beings who could observe and contemplate the cosmos that created them. The human chapter in this cosmic story is incredibly recent. If the entire history of the universe were compressed into a single year, modern humans would appear in the last minute of December 31st. Yet in our brief time, we have looked back through space and time to understand our cosmic origins. We've detected the afterglow of the Big Bang, observed distant galaxies forming, and begun to map the structure of the universe itself. Today, our understanding of cosmic history continues to evolve with new observations and discoveries. Space. Telescopes like James Webb peer farther into space and time than ever before possible. Gravitational wave detectors listen to the ripples in space-time, created by colliding black holes and neutron stars. Each new finding adds detail to our understanding of this grand cosmic narrative that connects all matter in the universe. Through astronomical observations and particle physics experiments, scientists have determined that ordinary matter, the stuff of stars, planets, and people, makes up just about 5% of the universe. The rest consists of dark matter and dark energy, mysterious components that don't interact with light or other forms of electromagnetic radiation. Dark matter, which constitutes about 27% of the universe, reveals itself only through its gravitational effects on visible matter. The discovery of dark matter and dark energy has fundamentally changed our understanding of cosmic history. Dark matter played a crucial role in the formation of galaxies, providing gravitational wells that helped ordinary matter clump together. Without dark matter, the universe might never have formed the complex structures we see today. Its invisible presence shaped the visible universe in profound and essential ways. When we look at distant galaxies, we're actually looking back in time. The light from a galaxy 10 billion light-years away began its journey toward Earth 10 billion years ago. This cosmic time machine allows astronomers to directly observe different epochs in the universe's evolution. By studying galaxies at different distances, scientists have pieced together the story of how these majestic structures formed and evolved over cosmic time. One of the most profound realizations in modern astronomy is that the universe appears to be finely tuned for complexity. If fundamental constants like the strength of gravity or the mass of the electron were even slightly different, stars couldn't form or would burn out too quickly to support life. This apparent fine-tuning raises fascinating questions about whether our universe is unique or perhaps one of many in a vast multiverse. As our cosmic story continues to unfold, astronomers are discovering thousands of planets orbiting other stars in our galaxy. These exoplanets come in a surprising variety of sizes and compositions, many quite different from the planets in our solar system. The quest to find potentially habitable worlds where life might exist or develop has become one of the most exciting frontiers in modern astronomy. For countless generations, humans have looked up at the night sky with wonder. Today, we understand that we are connected to those distant stars in the most fundamental way. The atoms in our bodies were forged in the furnaces of ancient stars that lived and died billions of years ago. As astronomer Carl Sagan famously said, "We are made of star stuff." Our very existence represents one way the universe has come to know itself. The age of the universe, approximately 13.8 billion years, is difficult to truly comprehend. To put this vast time span in perspective, if the entire history of the universe were compressed into a single 24-hour day, modern humans would have appeared in just the last second before midnight. Our entire recorded history, spanning roughly 5,000 years, would occupy just the final 100th of a second in this cosmic day. Our current understanding suggests that the universe will continue expanding at an accelerating rate. In the far distant future, perhaps trillions of years from now, galaxies beyond our local group will recede beyond our visible horizon. The universe will grow increasingly dark and cold as stars exhaust their fuel and eventually die out. Yet, this end is so unimaginably far away that countless generations of stars and potentially civilizations will rise and fall before then. As we look to the future, our exploration of the universe continues to accelerate with new technologies. Powerful telescopes, space missions, and advanced computer simulations allow us to test theories about cosmic evolution. Each discovery brings new questions, reminding us that our knowledge, though vast compared to earlier generations, remains incomplete. The greatest cosmic mysteries may still await discovery. The story of our universe is also the story of human curiosity and wonder. From ancient astronomers tracking the movements of planets to modern scientists detecting gravitational waves, we have continuously expanded our understanding of the cosmos. This quest to comprehend our origins connects us with countless generations before us who also looked up at the night sky and asked the same fundamental questions. Our journey through the history of the universe reminds us of both our cosmic significance and insignificance. We are tiny beings on a small planet, orbiting an average star in one galaxy among billions. Yet we are also the universe becoming conscious of itself. Through us, the cosmos has developed the capacity to contemplate its own existence, to unravel its mysteries, and to marvel at its beauty. As our understanding of the universe deepens, we face profound questions about our place within it. Are we alone, or is life common throughout the cosmos? Is consciousness a rare development or an inevitable outcome of cosmic evolution? These questions connect astronomy with philosophy, showing how the study of the universe's history ultimately leads us to reflect on the meaning of our own existence. The cosmic perspective provides a unique lens through which to view our earthly concerns. When we understand that all humans share the same cosmic origin story, that we are all made of stardust, it becomes harder to focus on the differences that sometimes divide us. Instead, we might appreciate our common heritage as children of the cosmos, participants in the grand story of a universe gradually awakening to itself.